All right, in this video, we're going to talk about the normal distribution. But before we get to that, we have to talk about another concept first. So let's start with an example, something that we kind of understand. Let's look at the quiz scores from two different class sections, Section A and Section B. And what do we notice about the classes? So let's start with that. So first thing I notice is that Section A, the scores are like really different, right? Like it goes all the way from a 1, somebody getting a 1 to somebody getting a 10. So they're very spread apart. Scores are very different and spread apart. But in section B, they're not very spread apart at all or different. Like they and the whole class like got very close in their scores. So the scores are close together and similar. All right. So first thing they ask us is find the mean for each section. Okay, so let's do that. For section A, I'm going to add together all of the scores. I'm going to write this out, but I'm probably not going to do this again. I'm just going to show what I'm putting into my calculator. So when I add that all up, it gives me 60. And then I'll divide by how many scores there are, and there are 10. So that's going to be 6. Okay, so the mean is 6 for class or section A. So for section B, I'm not going to show the adding it up. But when I do add them all up, no, I don't know why I wouldn't just show it. Let me just show it. Just take a second. And 4 different 7s. So it also is 60. And there's 10 of them. So it's also a mean of 6. So the mean wasn't useful. It didn't tell us much information. They have the same mean, but the scores are very different. So the first thing they introduce is this concept of the range. The range looks at the difference between the maximum value and the minimum value. So let's look at the range for each section. So for A, the maximum, that's the biggest value, is 10, and minimum is 1. So that one has a range of 9 because you're taking the difference or subtracting, right? For B, the maximum is 7 and a minimum of 5. So that one is 2. So that's meaning like the range and the score, the difference between the high score and low score is 2, whereas the difference in section A, the highest and lowest score is 9. So that tells us some more information. It kind of gives us an idea that A is more spread out than B. Okay. Okay, now let's look at section C here. Section C. So section C is even more crazy than section A and B. In this class, it's like you either got a 0 or a 10. So there's very similar scores, but you like scored really well or you bombed it. Okay, so let's find the mean for this section. So for section C, if I added all those together, let's see, there's 4 zeros and 6 10s. Let's see, 1, 2, 3, 4, 5, 6. Okay, so it's going to come out to 60 again. Shocker. So divided by 6, and that's going to give me, I'm sorry, divided by 10. Sorry, there's 10 of them. That gives me 6. Okay, but this one has a range of 10, right? 10 minus 0. So same mean, and its range is really close to A, but it's behaving very differently from A. Okay. So how is section C different from A and B? Well, first of all, it has even less variety of scores. Sorry, variety in scores, but they are very spread apart. So it's kind of this like combination between the two sets, A and B, sections A and B, right? It's this idea that A was they were very different scores and spread out. B was that they weren't very spread out and they were kind of similar scores. Well, section C is they're very spread out and they're very similar scores. So it's kind of using something that is in both of those sets. And that makes it not useful to talk about the range and the mean. So since we only have this limited information, the range isn't giving us all that much now anymore. So this is why we want to introduce this concept called the standard deviation. So the standard deviation is a different way of measuring how spread out the data is. So we can think of the standard deviation as the average distance data is from the mean. So to find it, we're going to kind of use a table and we're going to follow some steps. So let's use section A. And first thing they ask is to take each data value and subtract the mean. So we already found the mean. We know the mean is 6. So I'm going to use this table and I'm going to fill out the second column. And I'm going to take each data value and I'm going to minus the mean. So I'm going to take the data value of 1 here at the front. And I'm going to, right, this 1 right there, and I'm going to minus 6 from 1, which is going to come out with a negative. It's going to come up with -5. Okay, so then I go to the 2, and 2 minus 6 is going to come out to -4. Sorry, here I should actually write down what I'm doing here. So I'm doing 1 minus 6, which is -5, 2 minus 6, which is -4. Okay, so then this one's 4 minus 6, which is -2. Here, that's going to give me -2 again. I'm not going to write that one. Okay, 6 minus 6, that's 0. 7 minus 6. Wow, that was a sad looking 7. Let me fix it. That's a 1. 8 minus 6 comes out to 2. 9 minus 6 comes out to 3, and 3 again. I don't really need to write that then. And then 10 minus 6 comes out to 4. And those values that we just have here on the right, we're going to take and square them. And that's what we're going to do in the third column. So squaring, right, we're going to multiply it by itself. That's what squaring means. So I'm going to take -5 and I'm going to multiply -5 times itself. And negative times a negative comes out to +25. And then -4 times -4, that comes out to +16. -2 times -2 is 4. The next one's going to be 4 again. Okay, so 0 times 0 is 0. I hope you're okay with me writing that down. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. I'm going to get 9 again. And then 4 times 4 is 16. All right, so there we go. We did the squares. Now find the average of these squared differences. So that means I want to find the average of this column that I just did right here. So I'm going to add them all together. And here I'm going to write this down. And I didn't do this in the calculator ahead of time, so we'll do this together. 0, 1, 4, 9, 9, and 16. Sorry, that 4 is kind of sloppy. Let me clean it up. All right, so here I'm going to plug this in my calculator. Grab your calculator and do it too. All right, I am getting, oops, I definitely did not get the right answer there. I must have plugged something in incorrectly. Sorry, let me try that again. So 25, 16, 4, 4, 1, 0. I'm sorry, 1, 0, 1, 4, 9, twice, and 16. There we go, much better. So I'm getting 88. And then because there are 10 data values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, divide this by 10. Okay, oops. And you can do that on your calculator and you're going to get 8.8. All right, now take the square root of 8.8. So you might remember the square root is like the opposite of a square. And it looks like this symbol on your calculator. And if you have a scientific calculator, even if you're using a calculator on your computer, that's the square root symbol. So you're going to find it and take the square root of 8.8. And when I do that, I get a terrible decimal. I get 2.966, blah, blah, blah. Okay, so that is the standard deviation. And that's how you find it. Okay, so let's do that again for section B. So first step is you take the data value minus the mean, you square all of those numbers, you add them together and find an average, and then you take the square root. Okay, so let's do that for section B. Now, section B uses the same mean. Here, I'm going to use the symbol that we introduced in a previous section. It's called mu, and it looks like a U with a tail in the front. That represents mean, right? So we saw that in, I think, the formula section. Okay, so that's the mean for this section, section B. So I'm going to subtract each of these. Now this is going to be really boring because so many of them are the same. So 5 minus 6 is -1. This is -1, -1, -1. Okay, so 6 minus 6 is 0 and 0. And then 7 minus 6 is 1 and 1 and 1. Okay, wow, really boring. Okay, so this time when I multiply them by themselves, I get 1 here, here, and here. Same thing. Here I'm going to get 0 and 0. And then here I get 1, 1, 1, 1. All right, so boring. Okay, so let's add them up. That's going to be, so we're finding the average. So I'm going to total them up. That's going to be 8. And then I'm going to divide it by 10. So I'm finding the mean. Taking an average. We're finding the mean. Okay. So 8 divided by 10 on my calculator, I get 0.8. And now I'm going to take the square root of 0.8. And I'll use my calculator to do that. And I get the decimal 0.894, blah, 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 blah. All right, that's good. So there's the standard deviation. Okay, so let's look at that. The standard deviation in A is almost the number 3, 2.966, right? It's basically 3. But for section B, it's less than 1. So the standard deviation in A is much bigger than it is in B. And that makes sense based on the fact that the data is more spread out. But what we're saying is that on average, the data values in section A are a distance of 3 from the mean, whereas in section B, on average, they are a much smaller distance. They're very close, almost less than 1. And that makes sense because the mean is 6 and all of the data values are like within 1 of the mean. So it makes sense that they're very close together, that the standard deviation is super small. Okay, so now that we kind of have this concept of standard deviation, we're going to finally introduce the normal distribution. So again, let's use an example. Most high schools have a set amount of time between classes, which students must get to their next class. If you were to stand at a door, watch the students come in, think about how the students would enter. Usually you get a few early, then more, then a large group, and then a few stragglers, okay? And some people are probably going to show up late. So let's pretend that we collected some data, all right? We stood at a door, and these were the times that we got people in. The negative is going to mean that they came early, okay? 0 means they came exactly on time. And then when they have like a positive number, that's how late they are to class, all right? So I want to create a picture of this, and I'm going to use a bar graph to do that. So I'm going to go ahead and give myself a nice little drawing here. And let's see, I'm going to have -6, -5, -4, -3, 2, 1, and it's going to go all the way up to 5 minutes. So I'm just putting a little tick mark for every little minute. And what I'm going to do is for every person that goes into each category, we're going to kind of stack up the rectangle here. Okay. 3, 4, 5. All right. So this is the minutes. And this is how many people came in. Oops, I'm sorry. How many people? Okay. So for 6 minutes, there was only one person who came 6 minutes early. So I'm going to do a little rectangle there. Okay. For 5 minutes, there was 2 people who came in. Oops. Let me try to draw it a little bit closer. There we go. Okay. For 4 minutes, 2 people again. 3 minutes, there was 3 people who showed up 3 minutes early. 2 minutes, there was 2 people. 1 minute, there's 1, 2, 3, 4, 5 people there. For 0, let's see, on time, 1, 2, 3, 4, 5, 6. Ooh, okay, so here, let me add another tick mark. Okay, so 6, our biggest one yet. Okay, now these are people who are late. So 1, 2, 3, 4 people were 1 minute late. Be right about there. And then 3 people were 2 minutes late. Close to there. And then 3 minutes late, there was 1 person. And then 1 person 5 minutes late, and then nobody at 4 or 6. Okay, cool. There we go. So that's kind of what our bar graph looks like. So what we kind of see is this pattern, right? That they're starting off a little bit slower, and then they climb up and they get bigger in the middle, and then they start tapering off again. That's the kind of basic pattern. We call that pattern bell-shaped. But in statistics, which is kind of what we're looking at right now, they call that normally distributed. So we call that a normal curve. And normal curves, as I kind of drew nice and smooth, kind of look like this. They have this bell shape. In the middle would be the mean. And as it goes off to either side, it's the idea is the mean kind of is also where the median is. It's right in the middle. And it also happens to be where the mode is. It usually is the highest occurring value. So the mean, median, and mode kind of all line up on a normal distribution. They're centered in the center. And it kind of has this symmetry where about half of the data goes this way and half of the data goes this way. So it's splitting it right in two. Okay, now here's what's useful to us and what we're gonna take away from the normal distribution. If I were to look at the standard deviation on here, here's how it's going to end up looking. The standard deviation is going to stretch from the mean to a value about this far away from the mean. And that value repeats, I'm using SD to represent standard deviation, multiple times. So if I keep going 1 standard deviation above the mean and 1 standard deviation below the mean, as you can kind of see, it ends up kind of encompassing all of the data in about 3 standard deviations below the mean and 3 standard deviations above the mean. And that is typical. So most of the data is within 3 standard deviations. Okay, now what that actually leads us into is this concept called the empirical rule. So because of their similar shape, normal distributions actually follow a percentage based on the standard deviation. Now, in a previous video, we introduced this notation for standard deviation. It's a circle with a tail on it. This means standard deviations. That's what we found earlier with that table. And then remember that the U with the line in front or the tail in front, that's mu, and that represents the mean. This symbol, by the way, the circle with the tail on the top, that's called sigma. That's sigma in Greek letters. It's the lowercase sigma, actually. So this picture is indicating what's happening when you go. The mean is here in the middle, right in the middle is the mean. And then 1 standard deviation above and below, 2 standard deviations above and below, 3 standard deviations above and below. And here is what the empirical rule says. About 68% lie within 1 standard deviation of the mean. That's what this says. 68%. So that means all right here, this represents 68% of the data. Then 2 standard deviations is 95%. So you go a little bit further out, that's 95%. 3 standard deviation is 99.7. So all the way out here, that represents 99.7% of the data. All right. They call this rule, by the way, the 68, 95, 99.7 rule, as well as the empirical rules. It's been known by both names. And let's kind of use this idea with an actual example, this 3 standard deviations idea. But let's say we're told that the mean is 50 and the standard deviation is 6. So here I'm going to use my symbols. Mu equals 50, that's the mean. And then sigma equals 6. Okay, so I'm going to draw a bell-shaped curve here as best I can. And in the middle, that's the mean, which is 50. And then I'm going to go 1 standard deviation above and 1 standard deviation below the mean. So 1 standard deviation is a difference of 6 from the mean. That means if I add 6 to 50, I'm going to get 56. So that's taking and adding 1 standard deviation to the mean. If I subtract 6 from 50, that's going to give me 44. So that's 1 standard deviation below the mean. And I'm going to do that again. Here, I'm going to draw my line in the center just so I can kind of visualize that. Okay, so 1 more standard deviation above and below. So I'm going to add and subtract 6 again. So this means that if I add 6, that's going to be 62. So I'm adding 6 again. So I'm adding 6 to 50 twice. That's what I'm doing. I'm adding 6 twice. That's 50 plus 6 times 2. And then here I'm going to subtract 6. So that's going to be 38. So that's subtracting 6 twice from 50. And then I'm going to add 6 one more time, 3 standard deviations. Okay, so adding 6 one more time, that's going to give me 68. Subtracting 6 one more time, that's going to give me 32. Okay, so here's what that means. I'm saying that 99.7% of the data is between 32 and 68. So whatever this data is, whatever it's measuring, it's going to fall between about 32 and 68 are going to be like kind of close to the maximum and the minimum of the data. They're going to fall between those 2 values. And it's going to be about 99.7% of all of the data values are going to fall between those 2 values. Or if we look at the closer ones, we're saying about 68% of the data is going to be a value between 44 and 56. All right, again, it'll make more sense if we kind of look at it as an example. So let's consider this example. From 1984 to 1985, the mean height of 15 to 18-year-old males in Chile was 172.36 centimeters, and it was a standard deviation of 6.34 centimeters. So here, I'm going to draw this again, and I'm going to kind of squeeze it in here just to make it work. So here, I'm going to try to make it a little bit wider since we're looking at decimals. Okay. All right, so the middle value, that's the mean. And I'll use mu. Mu equals 172.36. And the standard deviation, sigma, is 6.34. Okay, so I'm going to, in the middle, that's the mean. Oops, I'm gonna use red. 172.36. And then I'm going to go 3 standard deviations above the mean and 3 standard deviations below the mean. So that means I'm going to add 6.34 3 times, and then I'm going to subtract 6.34 3 times. And I'm not going to show this, the adding and subtracting. I'm just going to do it on the calculator. So minus 6.34. Okay, so I'm getting let me switch back to red. 166.02. And then I'm going to subtract 6.34 again. And I get 159.68. Here, I'm going to zoom in a little because I'm writing so small. It's kind of hard to do. I'm going to spread them out a little bit. So sorry, this one was 166.02. 159.68. Okay, and then subtracting 6.34 again. 153.34. Okay, so now I'm going to come back to 172.36 and I'm going to add 6.34. So this is going to give me 178.7. Add it again. I'm getting 185.04. And one more time. And I get 191.38. Okay, so let me kind of draw my middle one here just so I can keep track. There's the mean, all right? And then 3 standard deviations above and below the mean. Okay, so 68% of the heights are between what two values? Well, 68%, that's 1 standard deviation above and below the mean. So that would be this one below and one above. So we're saying that 68% of the heights lie between 166.02 centimeters to 178.7 centimeters. So in Chile, these males between 15 to 18, that 68% of them are going to fall between those 2 centimeter values. So 95% would be between what 2 values? Okay, so 95% in the empirical rule is the next one out, 2 standard deviations from the mean. So 2 standard deviations, that would be right here and right there. So that would be 159.68 centimeters to 185. Oops, that's a 1. Sad looking 1. 0.04 centimeters. All right. And then the last one would be 3 standard deviations away from the mean according to the empirical rule. So it'd be the last 2 values, 153.34 centimeters to 191.38 centimeters. So 99.7% of all males 15 to 18 years old in Chile were between 153.34 centimeters and 191.38. So anybody outside of there was probably very rare. All right, very, very rare. And that's what the normal distribution kind of tells us. It helps us to see when information might be very rare. And we call that rare information outliers. All right, so let's apply this in a problem. Let's say there is a lake sturgeon that has a mean length of 114 centimeters and a standard deviation of 29 centimeters. If the lengths are normally distributed, what percent of the lake sturgeon had lengths between 56 and 143? Okay, so again, I'm going to draw my normal distribution, my bell curve. I'm going to figure out all my values, starting with the mean, and then 3 standard deviations above, and 3 standard deviations below. Okay, so the mean is 114. I'll use my mu just to get us used to it. And our sigma for the mean and standard deviation. Okay, so this time I'm going to subtract 29. And I get 85 and 29 again, 56, and 29 again gives me 27. Okay, and then 114 plus 29, 143 plus 29 again, 172, and plus 29 again, 201. Okay, so here we go. I see that 56, oops, wow. Let me, sorry. Oh, okay, now it switched to the highlighter. 56. Okay, sorry, 56, that's the lower one. And the higher one was 143. Okay, so we have a little bit of a problem because 143 is 1 standard deviation away from the mean, whereas 56 is 2 standard deviations away. So 1 standard deviation, we happen to know this is 68%. Oops, sorry, 68%. That's the empirical rule, 68%. 2 standard deviations we know is 95%. So here I'm going to kind of do it outside. 95%. Okay. So unfortunately, we can't just say it's 68% or 95%. It doesn't quite work. If they had said between 85 and 143, then we would have been like, it's 68%. Okay, but they didn't do that. So we need to actually figure out like what percents these two are right here. Like I can figure that out. And the way I'm going to figure that out is I'm going to subtract 95 minus 68. So that is going to equal what I have highlighted in yellow here. 27 is how much is left over from 95 and 68. So if I split that in half, each of these are 13.5%. 13.5%. So the answer is 68% plus 13.5% because I want to go up to 56, right? 56 is my magic number here to 143. So it's going to be, let me erase all these highlighters here. It's going to be all of this 68% and this 13.5%. So again, here, I'm going to erase all of this just so I can kind of visually see that. I have a lot drawing going on here, and I just want to, there we go. Okay, sorry. So let's re-highlight. So this plus that is going to be the percentage. Oops, no highlighter, please. So plus 68, and I get 81.5% of data are between 56 and 143. So the lengths of this sturgeon, 81.5% lie between those two lengths, 56 centimeters and 143 centimeters. And that is the normal distribution.